Hello students, welcome to Power Tutorials. So today we are going to cover question numbers 1 to 10 of exercise questions of Science Class 10 CBSE, that is NCERT textbook, that is the chapter 1, chemical reactions and equations. Okay, so in the previous I have already covered 3 parts of all the concepts which are present in this textbook, and also in the previous video I have covered the in-text questions, because in the textbook itself there will be in-text questions. So in the last video I have covered that in-text questions as well. So from this video we're going to cover the exercise questions 1 to 20. 20 are present. So in this video I'll cover 1 to 10. In the next video I'll cover the remaining 11 to 20. Okay, so I'll just show a glance which I covered in previous videos. So in the part 1 I have covered agenda, physical and chemical reaction, characteristics of chemical reaction. We also explained regarding the experiments which are mentioned in the textbook. And then you have explained symbol equation, what is balancing chemical equation and why we need to balance it. In part 2 I have explained about writing symbols of physical state, types of chemical reactions, and we covered 2 types of chemical reactions, combinations and decomposition. And also we have covered about endothermic and exothermic reaction in part 2. Okay, in part 3 I have covered the other types of chemical reactions which are decomposition. And decomposition we have 3 types: thermal, electrolytic and photolytic. And then displacement, what is displacement reaction and few examples. And then double displacement, oxidation reaction. And also I have covered what is rancidity and corrosion in the part 3. In the part 4, as I mentioned, I have covered the in-text questions which are present inside the textbook, each question with the detail along with the explanation, that is the equation. Okay, now let's start with the exercise questions, starting from question number 1. So what is question number 1? It is saying, which of the statements about the reaction are incorrect? So this is important, what they are asking. Incorrect, not correct statement. Okay, so because in the exams pressure sometimes you will miss what they are asking and they will just assume it as correct always, but there can be cases in the exam paper where they will say it's not correct. Incorrect statements they will ask you. Okay, let's see what are incorrect statements. So this is the equation. Lead is getting oxidized, lead is getting reduced. So lead is where lead is itself. Okay, so it is lead oxide is getting reduced to lead, but lead is getting reduced, so this is a wrong statement. Carbon dioxide is getting oxidized. Okay, this is also a wrong statement. Why? Because carbon is getting oxidized. Okay, in the previous videos I have explained oxidation is gaining of oxygen or reducing hydrogen. Reduction means reducing of oxygen or gaining of hydrogen. Here you can see lead oxide is losing oxygen to form lead, so it is reduction. Carbon is gaining oxygen to get carbon dioxide, so C to CO2 is oxidation, but which is getting carbon dioxide getting oxidized is wrong, lead is getting reduced is wrong, carbon is getting oxidized, this is correct statement. Lead oxide is getting reduced, this is also correct statement, but they are asking incorrect statement, which is wrong statements. Wrong statements are A and B. Okay, let's move to the second one. Fe2O3 plus 2Al gives rise to Al2O3 plus 2F2. The above reaction is an example of. So we have total 5 types of reactions: combination, decomposition, displacement, double displacement, and the last one is oxidation and reduction. So if you remember displacement reaction, why this is a displacement reaction I will explain you. Why? Because aluminium is more reactive than iron. So what it is doing, it is displacing the iron from its solution or oxide form, and the iron is getting out, and this is taking place of this iron place. So whenever any strong metal replaces or displaces the metal from its oxide or solution form, and that separates out into outside as separate element, then it is called as displacement. Since this is an example for displacement. This is the third question. What happens when dilute hydrochloric acid is added to iron fillings? So dilute hydrochloric acid is HCl. HCl if added with iron fillings, which is Fe, it forms FeCl2 plus hydrogen. Okay, so simple. It is hydrogen gas and iron chloride are produced. Small correction, it should be FeCl3 because valency of iron is 3. Okay, but here just asking for equation, it is hydrogen gas and iron chloride are produced. Chlorine gas and iron hydroxide, that is wrong. No reaction, yes, but here the reaction is taking place because iron is more reactive than hydrogen. So if they ask you what is the type of reaction, you have to say this is displacement reaction. Why? Because iron is displacing hydrogen. Let's see the fourth one. What is a balanced chemical equation and why should the chemical equation should be balanced? So a chemical equation in which number of reactants elements and products elements are same is called balanced chemical equation. So we can also give an example. Small example we can use, which is H2 plus Cl2 gives rise to 2HCl. 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. So why this should be balanced? Because it has to satisfy one law, which is law of conservation of mass. It has to satisfy law of conservation of mass. Where mass of reactants is equal to mass of products. Okay. Let's see the next question. Translate the following statements into chemical equations and then balance them. Okay. Hydrogen gas combines with nitrogen to form ammonia. So directly I am writing the symbol equation. Hydrogen gas is H2 combines with nitrogen, which is N2. This is forming ammonia, which is NH3. Ammonia is also gas. So hydrogen 2, hydrogen 3 here. Let's do 3 here and 2 here. Now we can see hydrogen is 6. Here also it is 6. Nitrogen is 2. Nitrogen 2. It is a balanced chemical equation. Next is second one. Hydrogen sulfide, which is H2S, burns in air. So if anything is burning in air, you have to use a gas which is oxygen, because this is the most combustible element which provides others to get burned. Okay, so burns in air means there is a presence of oxygen to give water and sulfur dioxide. Water formula is H2O, sulfur dioxide is SO2. So oxygen 2, but here oxygen total 3, hydrogen 2, 2, fine, sulfur is fine, only oxygen is not balanced. So we'll do one thing, we'll keep, okay, we need to multiply everything. Okay, fine, 2H2O, now oxygen become 4, 2 oxygen is fine. What about sulfur? Sulfur SS, hydrogen is 4 here but 2 here. Okay, again 2, 4 hydrogens, 4 oxygen, but here it is again 2. Okay, now it is 4 plus 2, 6 oxygen, so it is 3 O2. Now let's check. 4 hydrogen, 6 oxygen, 2 plus 4, 6 oxygen, sulfur is 2, hence it is a balanced. Let's see third one. Barium chloride with aluminium sulfate. Barium chloride means BaCl2. I'll do one thing, I will see the C and D in the next slide. Barium chloride, aluminum sulfate. Okay, barium chloride, aluminium sulfate. Aluminium is 3, sulfate valence is 2, so this becomes 2 and this becomes 3. Aluminium chloride, barium sulfate. Aluminium chloride, barium sulfate. Okay, let's balance this. Sulfate, this is a compound, so let's balance compound first. Sulfate 3 here, so I'll keep 3 here. Okay, next aluminum 2, chlorine 6, barium 3, it is already done, sulfate. Okay, everything is balanced. Let's see fourth one. Potassium metal reacts with water, potassium hydroxide, hydrogen. Potassium metal reacts with water, potassium hydroxide and hydrogen. Yes. Potassium 1, hydrogen 2, oxygen 1. Yes, it is already a balanced chemical equation. Let's move to the next question. Sixth one. They're simply asking to balance it. Okay. First one, let's write HNO3, which is hydrogen nitrate, plus calcium hydroxide, CaOH twice is hydroxide. Next, calcium nitrate and water. Nitrate, let's balance this because this is a compound, so always prefer balancing compound first. NO3 twice here, so I'll keep twice. Next, calcium is 1 oxygen total 6 plus 2 8 oxygen, so I'll keep here already 6 are present, 2 will be enough to make 8 oxygen. Hydrogen 2 plus 2 4, it is already 4, since it is balanced chemical equation. Let's see the second one. NaOH plus H2SO4, Na2SO4 H2, Na2SO4 H2. So SO4 it is already balanced. 2 Na, but here it is only single Na, so 2. Now let's check for hydrogen. 2 plus 2 4. Okay, now let's should be balanced. 2 oxygen, 2 oxygen, 4 hydrogen, 4 hydrogen. Yes, it is a balanced chemical equation. Let's see DC. NaCl AgNO3, NaCl AgNO3 gives rise to AgCl and NO3. AgCl NaNO3. So if you notice, all are already balanced because NO3, Ag, NaCl, Cl. It is already balanced chemical equation, so no need to do anything. Let's see D1. BaCl2 H2SO4, BaCl2 H2SO4, it should be BaSO4 and HCl. Let's see. Yes, BaHO4 and HCl. Okay, so hydrogen 2, chlorine 2, so simplify T keep 2 here, everything should be balanced chemical equation. Okay, let's move to the next question, which is seventh one. Write the balanced chemical equation for the following reactions. Okay, calcium hydroxide, which is CaOH twice, plus carbon dioxide, which is CO2, gives rise to calcium carbonate and water. So if you have seen my previous parts, this equation we already covered in the whitewashing part. So how the whitewashing is formed? If calcium oxide CaO is reacting with water, it forms calcium hydroxide. This has to be, it is in liquid form, it has to be coated on the walls to get whitewashing. So what happens later? The carbon dioxide which is present in the air will react with this calcium hydroxide to form it as calcium carbonate, which is like a strong layer on the wall, and that is nothing but the whitewashing, and the water which is present in that part will be evaporated as water vapor. Okay, so it is, let's see it is balanced or not. Calcium is balanced, carbon is balanced. What about oxygen? 2 plus 2 4, 3 plus 1 4, hydrogen 2, hydrogen already balanced chemical equation. Okay, let's see the next one. Zinc plus silver nitrate, zinc plus silver nitrate, which is AgNO3, gives rise to zinc nitrate plus silver, which is Ag. So zinc valence is 2, so this should be 2 here. Okay, let's balance this. Nitrate 2 here, so silver is 2. Okay, let's keep 2 here. Yes, this is a balanced chemical equation. Let's see third one. Aluminum and copper chloride. Aluminum is Al, copper chloride is CuCl2, gives rise to barium. Wait, aluminum chloride. Chlorine valence is 1, aluminum is 3. Okay, LCl3 plus copper. Copper 2, 3. So I will keep 3 here, I will keep 2 here. 2Al, 3C. Let's check. 6 chlorine, 6 chlorine, 2 aluminum, 2 aluminum, 3 copper, 3 copper. Done. Last one, barium chloride, potassium sulfate. Barium chloride, which is BaCl2, potassium sulfate, KSO4, K is 1, sulfate is 2. So K2SO4 gives rise to barium sulfate, potassium chloride. Barium sulfate, potassium chloride, which is KCl, but here we have 2K, 2Cl2, so this is 2KC. Okay, since this is also a balanced chemical equation. So now I am keeping a bonus topic which is not there in your textbook. So you have to remember valences of few elements and as well as few compounds as well. Okay, so what are the valences? Few elements only I am writing, which are mostly asked in the exam point of view. I am saying sodium is 1, chlorine valence is 1, and we have silver is 1, and then chlorine, silver. Okay, we have few compounds which you need to remember. So for compounds, mostly they will ask you sulfate, which is 2, carbonate, which is 1, nitrate is 1. Okay, and then we have calcium 2, barium 2. Anything else they're asking? Zinc 2, copper 2, zinc 2, copper 2, oxygen 2, hydrogen 1, magnesium 2, potassium, sodium 1. Potassium, sodium I think already covered. Okay. Potassium 1, zinc 2 is covered. Iodine, chlorine, bromine, all are ones because they belong to hydrogen, halogens. Fluorine they will not ask you, but they can ask you for bromine. Bromine is 1, chlorine is 1, already covered. Okay, so these valences you have to remember to get any chemical symbol. Okay, if anything is important I will just add it in the slide while doing this exercise questions. So as I mentioned, this is very important because the name we can remember easily, but for the symbols to write it as a compound we need to remember the valences. For example, if I say write the symbol for barium chloride, so barium, I told you here the barium valence is 2, so I will write barium here first. Barium valence is 2. Chlorine valence is 1. So what they will happen is this valency will move to this side and this valency move to this side, since the symbol of barium chloride is BaCl2. Got it? So just the valences will be interchanged to the below forms to get the respective symbol for the compound. Got it? So this way the valences are important. You have to remember all the valences to get this compound form. Let's see this question, 8th one, and I will use all the valences to mention in the previous part. Balance completion and also identify the type of reaction. Okay, here they are also asking to identify the type of reaction as well. So first balance it, potassium bromide. I will write the symbol just, then I will change it. Potassium bromide plus barium iodide, potassium iodide plus barium bromide. I haven't written the numbers because I will explain how to write the numbers. Potassium bromide, let's see, potassium is 1, bromine is also 1, so hence there is nothing to change, it is just KBr. Okay, what about here barium iodine? Barium, where is it? Barium is 2, iodine is 1. Okay, iodine I haven't written, iodine is 1. So barium is having 2, iodine is having 1, so if you just interchange it becomes BaI2. Okay, Ki, there is nothing to change. Again BaBr. Ba I told you it is 2, bromine is 1, so hence it becomes BaBr2. Okay, so just I have used the valences, wrote here, and then interchanged. So what is the type of this reaction? The type of reaction is DD, which is double displacement. So why it is double displacement? Because two metals are getting their positions interchanged. Barium to potassium and potassium to barium. So if any reaction, where there is a double exchange of reactions, I mean double exchange of metals or any elements, we call it as double displacement reaction. Second one, zinc carbonate gives rise to zinc oxide and carbon dioxide. Zinc carbonate gives rise to zinc oxide and carbon dioxide. Okay, so what is the valency of zinc? Zinc I haven't written. Yes, zinc is present, which is 2. So zinc is 2, carbonate is 1, so this becomes ZnCO3 twice. Okay, what about here? Zn is 2, oxygen also 2, so it is both are get cancelled out, it is CO3, sorry, ZnO, and then CO3. Here CO3 already told you the valence is 1, so no need to write it. Should be carbon dioxide is CO2, not CO3. Okay, CO2 valence is 0. So now let's balance this. CO3 twice is present, but here we have only 2 carbons. I will keep 2 here. Now let's check for oxygen. 2 plus 2, 2 2 is a 4, plus 1 5. Here it is 6. Somewhere missing anything. Okay, so small correction. Carbon valence is 2, not 1. Please correct it. Sulfide and carbon valences are 2 2, whereas nitrate valence is 1. Okay, so hence there is no need to change here. It is already balanced because they both are 1 1. And if you add, okay, here also no need to keep 2, it becomes carbonate. Carbon is CO2 is already balanced, which is 1 carbon and 2 oxygen, and 1 oxygen, total 3 oxygen. Here already 3 oxygens are present, so this is done. Let's see the C part. Hydrogen and chlorine, hydrogen chloride. Okay, so hydrogen is a gas, it is a diatomic molecule, whereas chlorine also gas, it's a diatomic molecule. It is forming HCl. Hydrogen valency 1, chlorine valency 1. You can see here hydrogen valence is 1, chlorine valence is 1, so both get same. But here 2 2 are present, so if you simply keep 2, it becomes. What about here, the chemical type here? This is called decomposition, where 1 is decomposed into 2 or more elements. What about here? This is a combination reaction where 2 or more are getting combined to form a single element. Okay, let's see the last one. Magnesium plus hydrochloric acid. Magnesium is a metal, so it will like just simple. Hydrochloric acid is HCl, gives rise to magnesium chloride and hydrogen. Magnesium chloride and hydrogen. So what is magnesium? Did I mention here? Okay. Magnesium is 2. So magnesium is 2, chlorine is 1, so this becomes MgCl2, because as I told you, valences will get interchanged to get the formula. So they have also mentioned regarding the physical states as well, so let's also write it. Potassium bromide aqueous, barium iodide aqueous. Aqueous is the one which is dissolved in liquid. Just a minute. So potassium iodide is aqueous, barium bromide is solid. Similar side for others. Zinc carbonate S, S and G. Hydrogen chlorine I already know it is gas. HCl can be gas or aqueous solution, but what they have mentioned, it is gas only, because they are saying that it is not acid form, it is in gaseous form. Okay, if the if dissolved in liquid, then it becomes, I mean water, it becomes aqueous, where that will be acid. Magnesium is solid, HCl should be, let's see what the acid or acid. Okay, that's why it is aqueous. MgCl2 should also be aqueous. Aqueous and hydrogen is correct. Okay, let's see two more questions for today, which is 9th and 10th. Ninth question. What does one mean by exothermic and endothermic reactions? Give examples. So this we already covered, but still I'll just a small gist. Exothermic, a chemical, or else simply I'll write chemical reactions where energy is getting released. Energy is getting released during a reaction. So for exothermic, we'll simply use all the combination reactions, because all combination reactions are exothermic. So I'll simply use coke plus oxygen, that is C plus O2 gives rise to CO2 and heat. So heat is nothing but the energy, hence it is exothermic. Now second one, endothermic. So endothermic is just opposite to the previous case, where energy is required to perform the reaction or to perform chemical reaction. So his example is water example, where electrolysis of water gives rise to hydrogen and oxygen gas in the presence of current, hence it is called as electrolytic decomposition. Let's balance this. 2H2, 2H2, 4 and 2 oxygen. You can also mention this is liquid state, that is water, but these two are gases. Okay, this is an example for exothermic and endothermic. Let's see the last question for today, which is why is respiration considered as exothermic reaction? So what is exothermic? I told you, where the energy is getting released. Even in respiration also energy is getting released. How? Because what is happens in respiration, the food what we take, for example potato, food taken is converted to glucose. This glucose reacts with oxygen to produce energy. Okay, hence the equation will be glucose is C6H12O6 plus oxygen 6CO2 gives rise to 6CO2 and 6H2. The main thing is energy. So as energy is getting released during this reaction, we call this reaction as exothermic. So this is nothing but glucose, this is oxygen, CO2 is carbon dioxide, H2O is water. Okay, so in this way all the 10 questions of today's session are be covered. In the next video we'll be covering the other 10 questions, which is 11 to 20 exercise questions will be covered. So this mostly will be covering tomorrow or day after tomorrow, and will be posted in the channel at 6 p.m. Okay, so please do subscribe and enable notifications so that you'll get notification for the next video. At the same time, as I mentioned, I am ready to provide one-on-one tuitions, that is online tuitions. If anyone is interested, you can send your details to the mail ID, which is powerclasses.snb@gmail.com. You can provide your number as well as to how many members they want one-on-one session. So based on it, we can connect. Provide your phone number as well. So I will call you back and we can discuss. If it is okay, we'll continue, or else it's up to you. Okay. So this is for one-to-one tuition, as I mentioned, or one-on-one personal classes. You can also call in that way. Okay. So thanks for watching. We'll connect again in the next video where I'll cover the exercise questions of 11 to 20. Thank you.